Hello everyone. For our lesson today, we are going to look at applying the different properties of similar triangles. You learned about similar figures in the last lesson, and this lesson we're going to be looking at triangles specifically. So the first property we're going to be looking at is the triangle proportionality theorem, which states if a line parallel to a side of a triangle intersects the other two sides, then it divides those sides proportionally. If I'm looking at this picture over on the right-hand side, I have two parallel lines, right? This line is parallel to the base. It cuts the side of my triangle into proportional pieces so that BX over XA is proportional, so is equal to BY over YC. Let's look at an example. If I look at this first picture with triangle SRT, I can see that line UV is parallel to the base ST, so that cuts my triangle into proportional parts. If I want to write that fraction, I know that RV over VT will equal RU over US. So let's write that. RV over VT equals RU over US. We want to find the measure of US. In order to do that, let's first fill in our values. So I know RV is 10. I know VT is 4. I know RU is 14, but I don't know the measure of US. So in order to find that, the first thing I need to do is cross multiply. We're going to multiply the 4 times the 14 and 10 times US. Well, 10 times US is just 10 US, and 4 times 14 gives me 56. Now I'm almost done. I'm down to my last step. In order to find US, I just need to get rid of that 10, and this is 10 times US, so in order to get rid of a multiply, I'm going to divide, and I get US equals 5.6. Okay, let's look at another question. Let's find the measure of PN in our second triangle. So if I look, this is my parallel line that's cutting my triangle into proportional parts. So I know that PN over PL will equal NQ over QN. So let's write that. PN over PL will equal NQ over QM. Then we're going to substitute our values in. I don't know what PN is, so I'm just going to keep that PN. PL is 3, NQ is 5, and QM is 2. So again, once I have this proportion set up, I am going to cross multiply 3 times 5 and PN times 2. Well, PN times 2 is just 2 PN, and 3 times 5 is 15. In order to get that PN by itself, I divide by 2, and I get PN equals 7.5. So that was the triangle proportionality theorem. Let's look at our second theorem for this lesson, which is the triangle angle bisector theorem. And what this one says is that an angle bisector of a triangle divides the opposite side into two segments whose lengths are proportional to the lengths of the other two sides. So if I'm looking at this triangle, I have an angle bisector right? This line bisects my angle into two congruent parts. And if I have that angle bisector, I know that the proportion of BD over DC will equal AB over AC. So again, let's look at an example. So if I want to find RT, well, first thing I want to look for is my angle bisector, which I have right here. QT bisects angle RQS. And what that tells me is that the proportion of RT over TS will equal QR over QS. So RT over TS will equal RQ over QS or SQ. Let's substitute our values in. I do not know what the length of RT is. That's what I'm trying to find. I know TS is 8, RQ is 6, and SQ is 9. So just like with my examples before with the triangle proportionality theorem, we are going to be cross multiplying. RT times 9 and 8 times 6. RT times 9 is just 9 RT, and 6 times 8 is 48. And again, our last step in order to get that RT alone, how do I get rid of a multiply? I will divide both sides by 9 to get RT is 5.3 repeated, or 5 1/3. And then my second example, I need to find LP. Well, I've got my angle bisector LN, which is bisecting angle MLP. So I know my proportion will be MN over NP equals ML over LP. So MN P MN is 4, NP is 3, ML is 5, and I do not know what LP is. So again, we will cross multiply. 4 times LP is 4 LP, and 3 times 5 is 15. Divide by 4, and we get LP is 3.75, or 3 3/4. So I do want to make sure I point out one additional fact before I let you guys go. Make sure when you're looking at your proportions, your sides line up. What that means is, if I look at this picture, BD is over DC, AB is over AC, right? However, you want to make sure that your values across from one another are in the same triangle. So if I look, BD and AB are in the same triangle. That is why those two are both on the top. DC and AC are in the second triangle, which is why they're both on the bottom. Okay. The same idea was with the other one as well. Make sure you're looking at the same sides. BX and XA were on the same side of the triangle, which is why one was over top of the other. BY and YC were on the same side of the triangle, which is why those two are over top of one another. So make sure your proportions make sense logically and they are lined up. That is all I have for today. Remember, if you have any questions, be sure to ask your teacher, and I look forward to teaching you again next week.